Hi dear students, today I will show you an electroshock weapon known as stun gun. This device was basically designed for the purpose of manifestation of self-defense and law enforcement. The aim of this project was to design, implement and package an electroshock weapon known as stun gun which is capable of incapacitating a human target without doing any permanent damage. The output of this gun is high voltage, low current pulsed electrical energy with 5 to 10 watt average power. This device has the ability to produce high voltage and low current pulses, and it can be used on any body, human body or any animal. It induces pain and temporary paralysis. It has no permanent effects, and the basic electrical structure is that it has a 9-volt input DC supply battery, and it is it has, you can see in the figure that in the whole circuit diagram that we have the blue colored capacitor for storing energy, then a power transformer having turn ratio of 1 ratio 200. It is used to boost this voltage from 9 volts to 2000 volts, and in front of the power transformer we have two MOSFETs, metal oxide semiconductor field effect transistors, and then we have a pulse transformer which boosts this 2000 volts to a high voltage of 30,000 volts. So this is a simple isolated boost flyback topology, and the input capacitor provides the current surges. The pulse circuit turns off the power supply when not needed. Each diode has a VBO of output of almost 700 volts. The transformer T1, the first transformer which I was talking about, the power transformer, its size constraint is around about 1 to 2 per centimeter cube. 1 to 2 centimeter cube is its size, and the high frequency of this transformer reduces its frequency is almost 100 kilohertz. As the frequency is higher, so the losses are also there. We have higher hysteresis losses, skin effect, proximity effect, different losses. But we can overcome those losses by applying some different circuit. And this transformer is basically a ferrite transformer. It is non-conducting ferromagnetic material, and it has many strands of small diameter wire. It reduces the skin effect. The energy storage and pulsing is done with the help of the capacitor, and this capacitor is filled with the help of the power supply, the input 9 volts battery. The pulse timing circuit fires the SCR, and the capacitor discharges through the pulse transformer. The pulse rate is around about 17 to 20 pulses per second. The energy requirements are, its energy, pulse energy is around about zero point 0.2 joules per pulse. We need zero point 0.2 joules energy per pulse, and the duration is almost 100 microseconds. So this was the whole circuit of electroshock weapon, commonly known as stun gun. Now I will go in very detail about about the total working of this whole circuit that how it works and what are the functions of the components used in this whole circuit. Let's go briefly. This stun gun is basically, the purpose is to produce high voltage, low current electricity to inflict temporary damage to its subject. This damage may include severe pain, involuntary muscle contractions, and temporary paralysis. The electrical signal at the output of the stun gun has to be applied to the subject's body through the electrodes. If there is any insulative layer between the electrodes and the body, it has to be broken down electrically, otherwise, the current will not flow and the effects will not be achieved. Now, this is done by applying a high voltage between the electrodes at the start of each pulse. You can see these two electrodes. We apply high voltage at these two electrodes. I will show you its working at the end of this video. So this stun gun is usually driven by the battery or set of batteries. We have used these batteries. You can see these silver colored batteries. We have this battery, and this battery is about 9 volts lithium polymer battery. So the basic aim of the stun circuitry is to step this voltage up to a very high open circuit voltage that is enough to cause electrical breakdown for at least 1 centimeter air gap. This air gap is round about 3 centimeter, and for 1 centimeter air gap 10,000 volts are required to break a 1 centimeter air gap. So as this is a 3 centimeter air gap, so we need 30,000 volts to break this air gap. So in our stun gun we implemented the stepping up in two stages. The first stage of stepping up steps the 9 volts battery voltage to around 2000 volts, 2 kV. In this stage we used a simple high frequency power transformer with high turn ratio of around about 200. The designing of the code geometry and its required turns on each side of a transformer in a small size proved to be quite difficult and error prone. So, before doing the primary stepping up, the DC electrical signal from the battery has to be converted to alternating current so that the transformer can step it up. For that purpose, we used a driver circuitry. The basic aim of the circuitry is to convert the constant electrical signal into a varying electrical signal that can be applied at the primary side of this transformer T1. As you can see, I am pointing the finger towards this transformer. This transformer I am talking about, the first transformer known as power transformer. The secondary stepping stage converts the output of the first stage into a very high voltage pulses, and for that we have used this pulse transformer. This transformer is a very high output voltage producing transformer, producing round about 30,000 volts. So two approaches were successfully implemented for this. One was voltage multiplier and the second was energy storage and pulsing through the pulse transformer. So we have done this second approach. We could have done this voltage multiplier approach too, but that was more convenient for us, so we did this one. So the first approach was not used by us. So you can see that after this pulse transformer we have two MOSFET oscillators. These are oscillator circuits. They produces oscillations. MOSFET is usually abbreviated as metal oxide semiconductor field effect transistor. So in the primary stepping up I was talking about this one, that the oscillator output is fed to the transformer T1 for stepping up, and the details are that the input voltage of the battery is 9 volts, the input current is 0.6 ampere, the output voltage of this pulse transformer is 2000 volts, and its output current is 20 milliamperes. Now the transformer's output voltage is passed through the half bridge rectifier for the rectification. These are two rectifiers. You can say call them rectifiers too. So this rectified energy is stored in 100 nanofarad 2000 volt capacitor, as you can see this one. Polyester capacitor is used to their high dielectric strength. This means that high voltage capacitors can be made relatively small. Also, these capacitors are able to withstand sharp voltage changes. Now, in the triggering stage, the energy stored in this capacitor is converted into pulsing using triggering stage. These pulses are fed to the second transformer. I am pointing finger on this second pulse transformer for secondary stepping up. The energy of the pulse transformer is controlled by the voltage of the triggering stage and the capacitance of the capacitor. Higher the voltage at which triggering is done, the more energy will enter into the pulse transformer that will result in higher output voltage pulses. Since higher triggering voltage will result in increased charging time, it will slow down the pulse rate. Therefore, high input current is required to maintain the pulse rate. So, two types of triggering is used in this stun gun. Uncontrolled triggering one type is, and the second is controlled triggering. In uncontrolled triggering, the pulse rate is not controlled by the external source, rather the circuit is designed in such a way to get required pulse rate, and you can see this whole circuit as we have designed this so we can control the triggering. So the capacitor's capacitance results in increasing the charging time, therefore large value of capacitor will lower the pulse rate. So this is the main purpose of using this capacitor, that it increases the capacitance and hence decreases the pulse rate because of the increase in the charging time of the capacitor. Now you can see these two white colored, I can zoom it, these two white colored gas discharge tubes, we call it. A gas discharge tube is basically a glass enclosed device. You can see that it is a glass enclosed device and it contains a gas mixture between two electrodes. So this gas discharge tube conducts electric current when the high voltage across its electrode ionizes the gas entrapped between those electrodes. It can conduct a high amount of current for the size and can handle some very large transients or small transients. So these gas discharge tubes also take a long time to trigger, which permits a higher voltage spike to pass through before conducting a significant amount of current. So we used 1600 volt gas discharge tubes in this circuit. Both are 1600 volts. So it triggers when the capacitor voltage reaches 1600 volts and allow the pulse to pass through it. This pulse is further fed to the pulse trigger transformer. This one, it is fed to this pulse trigger transformer for further stepping up. So if suitable, the voltage gas discharge tube cannot be found. These gas discharge tubes can be connected in series to get the required voltage. As you can see, I have connected these two in series. So it is a type of uncontrolled triggering. The next is spark gap triggering. As you can see the gap, in spark gap triggering, the two metal strips held at their specific distance upon the triggering voltage and the pulses, they are passed through the air. The sparks jump between the two metal strips in air on providing high voltage across it. The distance between these strips depends upon the voltage at which the triggering is required. For example, 1 millimeter distance between electrodes is set for triggering around 1000 volts. So for triggering around 2000 volts, the distance is 2 millimeter. But here in this case, we have 3 centimeter distance. So for every 1 centimeter distance there is a spark gap of 10,000 volts. So we have 3 centimeter distance, so this is 330,000 volts generated at the output. You might be quite curious about how it will work. We will show you after the end of the video, so don't worry about that. So this was the main function of this entire circuit. This is a very deep uh, discussion, but I think it's enough for now. Now we go to the functioning part. This is basically a handheld device. We have designed this on our own. You can see this is the button for triggering, and this button operates this stun gun. So when I will press this button, you will see a spark and you will hear its noise. You can hear this noise. You can also see that here in this gas discharge tube, due to that gas which is being ionized, you can also see the color of that gas. You can see here, and similarly here. So this is the main functioning of the entire circuit of electroshock weapon. And this circuit is basically used, this stun gun is basically used for the law enforcement by different intelligence and forces agencies, because due to the increase in the crime rate today, nowadays, many forces and agencies use this stun gun. We could also have added a different thing here, and which is called teaser. It has a spring and it fires upon that target and it creates that voltage, but we have not put that thing because it would have been more troublesome. So this was the main functioning of the entire circuit. Hope you have enjoyed this video. Please subscribe to our channel and refer this to your friends. So for now, goodbye, and hopefully you will see next video more interesting videos about technology